Kenapa ni?
Okey, boleh mulakan sekarang. Ecah mana Ecah?
Ada, dengar tak?
Can hear you.
Okay. Sekejap ah. Sekejap eh. Okay. Assalamualaikum dan selamat petang kepada Dr. Faizwan dan rakan-rakan sekalian. So hari ini kita akan teruskan dengan presentation yang ketiga iaitu untuk application Voltammetry. So untuk first presentation saya menjemput grup pertama dengan tajuknya Analytical Investigation of Paracetamol on Glassy Carbon Electrode by Voltammetry. So group first dipersilakan. Duduk.
Okay, boleh start ya?
Start.
Okay, thank you Aisyah Zalzami. So, Assalamualaikum and good evening to Dr. Faizwan and my fellow friend. So, the title of the journal that we found is Electroanalytical Investigation of Paracetamol on Glassy Carbon Electrode by Voltammetric. Next. Okay. First one is type of voltammetry. There are two types of voltammetry technique, and the first one is differential pulse voltammetry (DPV), and the second one is cyclic voltammetry. So the parameter that were employed are pulse amplitude, pulse amplitude 50 millivolt, pulse time 0.04 second, voltage step 0.09 volt, voltage time 0.04, and Syarika tak nampak bawah tu.
Macam mana tutup ah? Okay.
Back. Batch application. Okay. And the last one is potential step, 10 millivolt. And for cyclic voltammetry, the range of scan rate is 10 to 1000 millivolt per second. Next.
Stop ya.
Kenapa tengah?
Sekejap ada masalah.
Oh, okay.
Right.
Hello, boleh dengar tak?
Okey, boleh dengar.
Okay.
Dengar dah.
Dengar. Okay, in this study, basically a 3-electrode system is used. For the working electrode will be the glassy carbon electrode, auxiliary will be the platinum wire, and the reference electrode is the silver chloride with the potassium chloride 3 mole per liter. Next. So why we use glassy carbon electrode? Because Pge has a large diameter of working area and it allows measurement in a wide potential range, which is from negative 2.0 to positive 2.0. This electrode also has fast electron kinetic due to its high electron transfer rate on the electrode surface, and the electrode can be reduced by polishing with alumina on an alumina polish pad before each experiment. Next.
So for the sample, we use a tablet of paracetamol from Atabe. It is from Istanbul, Turkey. So the picture is the example for the sample.
Next is Analyte. So paracetamol, also known as acetaminophen. So it is a major ingredient in numerous cold and flu medications and many prescriptions. Analgesics is a drug that acting to relieve pain. Paracetamol acts as a painkiller by inhibiting prostaglandin synthesis in the central nervous system. So many techniques have been used for the detection of paracetamol, like HPLC, spectrometry, chemiluminescence, capillary electrophoresis, and Vertimetry. But these methods are tedious, high cost, and require pre-treatment of sample. So we use Voltammetric that offer high sensitivity, precision, low cost, and accuracy. So why we need analyze this paracetamol for the determine the exact amount of paracetamol inside the tablet. So we do not want excessive amount of paracetamol have on the inside the tablet. Okay, next.
Okay, next
For the concentration of analyte, okay, so as we know that analyte is the paracetamol, so the concentration range from 4 exponent negative 6 mol per liter into 1 exponent negative 4 mol per liter. The limit of detection is 3.69 exponent negative 7 mol per liter, while the limit of quantification LOQ is 1.23 exponent negative 6 mol per liter. Okay, so here is the supporting electrolyte that have been prepared, and the solutions are protected from light and were used within 24 hours to avoid the decomposition. But then, when we form the study, the highest and the good share of peak can be observed at the pH of 4.51 of 0.2 molar acetate buffer. Therefore, it is chosen as the electroanalytical analysis. So next is
So for the result, we have the type result, which is first, electrochemical oscillation behavior of paracetamol, and second, validation of the proposed Voltammetric technique, and the third is determination of paracetamol in tablet form by Voltammetric techniques. First, for electrochemical oscillation behavior of paracetamol, in order to obtain the optimal experimental condition, different type of pH and supporting electrolyte were studied as shown in figure 1. So for from the peak, we choose the pH of 4.51 and 0.2 molar acetate buffer. So from the figure, we can see for the A is the phosphate buffer at pH 5.45, and for the B is acetate buffer, and C is for the BR buffer, and the highest is the sulfuric acid. So the next is the peak potential for the oscillation peak shift from 0.7 to 0.1 values with increasing pH. We can refer figure 2. So this indicates that the voltammetric response was strongly pH dependent. So the effect of the scale rate from 10 to 1000 on the peak potential and the paracetamol peak current were evaluated with we can see from figure 3, and with increasing scale rate the anodic peak current increased. So the electrochemical oscillation process was carried out using CV technique. The CV voltammogram of paracetamol exhibit only one anodic peak with no peak on the reverse scan. It indicates the totally irreversible nature of the electrode reaction. Therefore, the oscillation process of paracetamol was proved to be irreversible.
Okay, from this study, approximately 2 protons were transferred in the reaction. Paracetamol oxidation is a 2 electron and 2 proton process as shown in scheme 1 below. So, next. For the second part, which is validation of the proposed voltammetric technique, a linear relationship between the oxidation peak current of paracetamol at GCE and concentration was established as in figure 4. Validation of the procedure for the quantitative determination of paracetamol was examined using evaluation of LOD, LOQ, repeatability, reproducibility, recovery, accuracy, and precision. The equation of the linear regression plot was IP over mu A ampere equal to 2.2 exponent 4 molar and the correlation coefficient is 0.9989, and it is repeated for 5 times. So below is the results. Next. For the last part, which is determination of paracetamol in tablet form by voltammetry techniques. So this is the result where in the labeled paracetamol, where 500 milligram of paracetamol is on the label, and the amount found is 495.71 milligram. The RSD is 0.72, bias percentage is 0.89, paracetamol spike is 40 milligram, the amount found is 39.32, the average recovery percentage is 98.3, the RSD is 1.7, and the bias percentage is 1.86. So the results show the validity of the proposed technique for the quantitative determination of paracetamol in tablets. Okay.
For the conclusion, a simple selective DPV technique for the quantitative determination of paracetamol based on the electrochemical oxidation at GCE was established. From the CV and DPV measurement, it is understood that the electrode reaction process is irreversible and pH dependent. And paracetamol was successfully determined in acetate buffer with 5.1 in tablet doses by DPV technique. The principal advantage of the DPV technique over the other techniques is that it may be applied directly to the analysis of pharmaceutical dosage form without the need for extensive sample preparation. And the other advantage is that the developed DPV technique is rapid. So that's all. Thank you.
Okey, terima kasih kepada kumpulan pertama. Ada apa-apa soalan? Doktor ada soalan? Okey, tak ada. Diteruskan dengan kumpulan yang kedua akan membentangkan tentang Voltammetric determination of Pyridoxine, vitamin B, which is vitamin B6 by use of a chemically modified classic carbon electrode. Dipersilakan.
Nampak ke slide?
Nampak.
Nampak.
Okay.
Okay, Assalamualaikum and very good evening to Doctor and to all our friends. Today we will present about our topic. The first part is about the type of voltammetry used in this experiment. There are two types, which is first cyclic voltammetry. This is a specific type of voltammetry that is an electrochemical potential dynamic measurement that allows study of redox properties of compound and interfacial structure. And it can quickly provide qualitative information about catalyst and electrochemical reaction, such as electrochemical response of catalyst, the interaction of catalyst with the electrolyte, and also the catalytic activity of the catalyst. For this experiment, we use this cyclic voltammetry exactly for determine the electrochemical behavior of vitamin B6. And prior to and after every measurement, the multi-wall nanotube modified glassy carbon electrode underwent cyclic voltammetry sweep between 0.50 and 1 to 10 volt at 100 millivolt per second in pH 6 phosphate buffer until the voltammogram are stable. Next. The second one, we use different pulse voltammetry, which is a technique that involves applying amplitude potential pulse on a linear ramp potential. In this method, the current is sample twice, which is the first just before the pulse is applied and the second just before the pulse ends. The two measurements are subtracted. I'm so sorry because of the error that. We will measure the different current by subject the first and the end of the pulse. The calibration curve for pyridoxine in pH 6.0 phosphate buffer was measured by different pulse voltammetry. The best parameter for this experimental on multi-wall nanotube film coated by the classic carbon electrode are accumulation time for 2 minutes, pulse amplitude for 50 millivolt, and for the scan rate, we use 20 millivolt per second, and lastly for the pulse width for 50 milliseconds. Next, we go to the type of electrode. Thank you.
As for the type of electrodes, three electrodes are involved, which are MWNT. MWNT stands for multi-wall carbon nanotube, full modified classic carbon working electrode, and then we have saturated calomel reference electrode SCE, and last but not least, we have platinum wire counter electrode. As for MWNT full modified GC working electrode, it was involved in the process of fabrication, to which 5 mg of MWNT and 5 mg of dihexadecyl hydrogen phosphate PHP were dispersed into 5 ml of redistilled water. Then they were sonicated for 20 minutes in order to obtain stable and homogeneous MWNT DHP suspension. And then the GCE was mechanically polished with alumina paste of different grades to a mirror finish and was then rinsed and sonicated for 3 minutes in redistilled water. Last but not least, the GCE was coated with 5 microliter of MWNT DHP suspension and allowed to evaporate water at the room temperature in the air. All right, next.
Okay, sample that is being analyzed in this study is tablets. So in this study, 10 tablets was used and finely powdered. Next. Okay, next is analyte that is being analyzed. It is pyridoxine. Pyridoxine, also known as vitamin B6. So vitamin B6 is a part of the B group vitamin and is required for both mental and physical health. This vitamin is also an essential vitamin to aid in the formation of healthy red blood cells, and it also supports more vital bodily function than any other vitamin. For example, this vitamin is needed for more than 100 enzymes involved in protein metabolism. And the nervous and immune system need vitamin B6 to function efficiently. A vitamin B6 deficiency can result in a form of anemia that is similar to iron deficiency anemia. Next.
Okay, the next one is concentration of the analyte. Okay, based on the result, the journal, analyte concentration is obtained in mole per liter. A sensitive linear voltammetric response for pyridoxine was obtained in the concentration range within 5 exponent -7 to 1 exponent -4 mole per liter. Okay, this linear voltammetry is obtained using the different repulsive voltammetry. Different pulse. Okay. Okay, the detection limit is 2 exponent -7 mole per liter, which is 33 ppb. Benda tu.
Okay, now we go into the result and discussion. So for the result and discussion, we will be covering 7 parts, which are electrochemical behavior of pyridoxine, optimization of supporting electrolyte, effect of the amount of multi-wall carbon nanotube DHP suspension on GCE electrode, optimization of accumulation conditions, calibration graph, the effect of interferences on the determination of pyridoxine, and lastly, analysis of pyridoxine in tablets. Next. Okay, so for the electrochemical behavior, in the potential window between 1.1 volt to 0.5 volt, there was no reduction peak observed for the multi-wall
multi-wall carbon nanotube modified glassy carbon electrode. So when 50 micromolar pyridoxine is added into the buffer solution, an oxidation peak was observed at the potential of 0.80 volt. And when the potential is swept from 1.1 volt to 0.5 volt, there was no reduction peak observed. So this shows that the redox reaction of pyridoxine is irreversible. As you can see in this cyclic voltammetry, there was no reduction peak observed in the voltammogram. Okay, next. So after second cyclic voltammetric sweep, the current peak decreases and finally unchanged, and this is attributed to the absorption of the product of oxidation at the electrode. Different scan rate was applied from 10 to 200 millivolt per second, and it was observed that even at 10 millivolt per second, the oxidation peak is still present in the voltammogram, indicating that the reaction of pyridoxine on electrode is irreversible. So the electrocatalytic effect of multi-wall carbon nanotube electrode was also investigated using 3 different working electrodes, which are bare glassy carbon electrode, DHP film modified glassy carbon electrode, and multi-wall carbon nanotube DHP film modified glassy carbon electrode. So in this voltammogram, we can see that at part A, which is the bare glassy carbon electrode, 50 micromolar of pyridoxine produces a very low oxidation peak at the potential of 0.85 volt. And at B, which is for DHP modified GCE, the oxidation peak decreases 2 times of the bare GCE, as the DHP, which stands for dihexadecyl hydrogen phosphate, inhibits the electron transfer between pyridoxine and electrode. And for C, which is multi-wall carbon nanotube modified GCE, the oxidation peak increases significantly, and the peak is shifted towards more negative potential at 0.80 volt. And this shows that multi-wall carbon nanotube modified GCE greatly enhance the sensitivity in determining pyridoxine due to its large surface area and also strong adsorptive ability. Next. Okay, the second one is optimizing supporting electrolyte. So in this part, various buffer systems were used to obtain the optimum pH for the determination of pyridoxine. So the buffer medium used are phosphate buffer with the pH of 5 to 8, sodium citrate HCl buffer from pH 1 to 5, McVeigh buffer from pH 2 to 8, and Britton-Robinson buffer from pH 2 to 10. So by comparing the cyclic voltammetry for each and every buffer above, it was found that 0.1 molar of phosphate buffer at pH 6 gives the highest current peak, and the peak shape is well defined. Thus, 0.1 molar phosphate buffer at pH 6 was chosen to be used as a medium for pyridoxine oxidation in the cyclic voltammetry. The third one is the effect of the amount of multi-wall carbon nanotube DHP suspension. The amount of multi-wall carbon nanotube DHP suspension on the GCE surface directly determines the thickness of the multi-wall carbon nanotube DHP film. Multi-wall carbon nanotube is a material with excellent electrical conductivity, and ideally, the oxidation peak current is almost independent to the thick of multi-wall carbon nanotube film. However, DHP is an insulator and it blocks the electron transfer on the electrode. Due to the lowering electronic conductivity on the cast film on the GCE surface, the peak current conversely decreases when the multi-wall carbon nanotube film is too thick.
Proceed to the optimization of accumulation condition. The influence of accumulation potential on the oxidation peak current of pyridoxine was examined. the oxidation peak current of 2 times 10 to the power of negative 6 mole per liter pyridoxine was compared after 2 minutes of accumulation under different potentials. So the result shows that the peak current almost remained unchangeable as the accumulation potential shift from negative 0.2 to 0.5 volt. This shows that the accumulation potential had no effects on the oxidation peak current of pyridoxine at the multi-wall nanotubes modified classic carbon electrode. Therefore, an open circuit accumulation was employed. So this figure shows the influence of accumulation time on the oxidation peak current of pyridoxine. As you can see from the graph, the oxidation peak current increases significantly within the first 2 minutes and the current becomes stable after 2 minutes. This suggested that the accumulation of pyridoxine at the multi-wall carbon nanotube modified classic carbon electrode is very rapid to reach saturation. Next. For the calibration graph, the calibration curve for pyridoxine in pH 6.0 phosphate buffer was measured by differential pulse voltammetry. The base parameter on the multi-wall carbon nanotube film-coated glassy carbon electrode are 2 minutes of accumulation time, 50 millivolts of pulse amplitude, 20 millivolts per second scan rate, and also 50 milliseconds of pulse width. For the multi-wall carbon nanotube modified glassy carbon electrode, the linear segment increases from 5 times 10 to the power of negative 7 to 1 times 10 to the power of negative 4 mole per liter, with a regression equation of IP current equal to 0.05 plus 0.61 times 10 to the power of 6 C concentration. So it is found that this method can detect 2 times 10 to the power of negative 7 mole per liter pyridoxine after 2 minutes of accumulation via the experiment. The RSD was 4.9%, which showed good reproducibility. However, for bare glassy carbon electrode, the linear range is from 7.5 times 10 to the power of negative 6 to 1 times 10 to the power of negative 4 mole per liter, and the detection limit is just 3 times 10 to the power of negative 6 mole per liter, which is higher than the modified glassy carbon electrode. Next. Besides, the long-term stability of the multi-wall carbon nanotube modified glassy carbon electrode was evaluated by measuring the current responses at a fixed pyridoxine concentration for 3 weeks. The electrode was used daily and stored in the air. The experimental result indicated that the current responses deviated only 5.2%, revealing that the multi-wall carbon nanotube modified glassy carbon electrode fabricated through this method possesses long-term stability.
Okay, so for the studies for interferences, to evaluate the interferences of foreign species on the determination of pyridoxine at the level of 2 times 10 to the power of negative 6 mole per liter, a systematic study was carried out. From the table 1, it is found that MWNT modified GCE can tolerate interference from other organic compounds. For example, 10-fold concentration of vitamin B1, vitamin B2, vitamin B12, vitamin C, 30-fold concentration of uric acid, dopamine, vitamin A, and 50-fold concentration of vitamin E, progesterone, and caffeine almost does not influence the current response of 2 times 10 to the power of negative 6 mole per liter pyridoxine. This shows that the proposed voltammetric method has excellent selectivity towards pyridoxine. Next. So for the analysis of pyridoxines in tablets, the average mass of 10 tablets was determined and finely powdered. Then the required amount of sample to prepare a solution of calibration to 10 to the power of negative 3 mole per liter was transferred into a 100 ml standard flask containing 80 ml of phosphate buffer at pH 6. Contents of flask then were stirred magnetically for 15 minutes and then diluted to a volume with the same supporting electrolyte. The solution was filtered and the first 20 ml of the filtrate was removed. Then appropriate solutions were prepared by taking a suitable aliquot of the clear filtrate and diluting them with supporting electrolyte. Voltammograms were recorded as in standard pyridoxine, and the content of pyridoxine was calculated from the regression equation and the results shown in table 2. Next. The result obtained by MWNT modified GCE are in good agreement with the declared pyridoxine content, where the percentage recovery is quite high, which is for the first sample is 102.4, sample 2 is 101.6, for sample 3, 99.7%, for 4, 99.4%, and for the fifth, 100.8%. In order to establish the suitability of the proposed method, known amount of the standard pyridoxine were added into the analytical solution of the pyridoxine tablets, and the same procedure was applied. The recoveries indicate that the accuracy and repeatability of the proposed voltammetric method are very good. For experimental result, it is clear that this novel MWNT modified electrode has great potential for practical sample analysis. Next. So for this, as the conclusion, it is important and useful to develop a sensitive and convenient method for the measurement of pyridoxine, a novel chemically modified electrode, MWNT modified GCE, being developed for the determination of pyridoxine. Due to the properties of MWNT, which is high specific surface area, subtle electronic properties, and a strong adsorptive ability, the MWNT modified GCE shows a remarkably electrocatalytic ability to the oxidation of pyridoxine. MWNT modified GCE greatly enhanced the determining sensitivity of pyridoxine. That's all from us. Thank you. Ada soalan? Tak ada. Okey. Terima kasih kepada grup 2. Seterusnya, kita teruskan presentation oleh grup 4 dengan tajuknya Gold Nanoparticles Electrode Deposited on Glassy Carbon using Cyclic Voltammetry, which is application to Mercury 2 trace analysis. Dipersilakan.
Assalamualaikum.
Salam.
Okay. Our topic, our title of journal, journal is Gold Nanoparticles Electrode Deposited on Glassy Carbon using Cyclic Voltammetry application to Mercury 2 plus trace analysis. Okay, next. Okay, first of all is type of voltammetry technique used. Okay, the technique used is cyclic voltammetry. So in the cyclic voltammetry, we have analytic shaping voltammetry, ASV. So in this journal, the technique that we use is square wave analytic stripping voltammetry, SWASV. So basically, the technique is the combination of pre-concentration step like ASV with pulse technique, which is square wave, that allow detection limit in the picomolar range to be reached. So the authors state that there are 4 reasons why they choose the square wave analytic stripping voltammetry. First, it is indicative of the occurrence of adsorption phenomena, either of the reactant or the product, and give also insight of the presence of intermediates in the gold 3+ reduction mechanism. Okay, second, the relative importance of mass transfer phenomena versus heterogeneous electron transfer can be discriminated. Okay, yang third is the shape. The shape of the cyclic voltammegram is characteristic of nucleation and growth process. And fourth is cyclic voltammetry enables the determination of the optimal condition for gold nanoparticles electrode deposition, such as potential range, gold, delta chloride concentration, and etc. So next, Chen Yu.
Hello, boleh dengar ke tak?
Dengar.
Okay, now we are going to present about the type of electrode used. The type of electrode used in this study is the glassy carbon electrode with the electrode deposition with gold nanoparticle with the abbreviation of aluminum nanoparticles GC electrode. It is the electrode in which the glassy carbon is modified to have the gold nanoparticle attached to the surface. Before the modification, the glassy electrode is firstly cleaned by alternately polishing the surface with grinding papers and with the ultrasonic ethanol bath for 3 times. After the polishing, the electrode is rinsed by ultra pure water bath and then dry with nitrogen stream. This electrode will be modified with the cyclic voltammetry scanning under the solution of sodium nitrate deaerated solution containing the 0.25 millimolar hydrogen gold chloride at pH 3, where the gold nanoparticle will attach to the surface as the ion. The resulting electrode will then activated by having a cyclic voltammetry scanning in between 0.2 and 0.4 volt in the sulfuric acid. If the electrode is not activated, the accuracy of the electrode will decrease. Okay, that's all for me. Next slide, please.
So next example that we studied, mercury appears to be one of the highest priority targets from the activity for biological compounds. So bioaccumulation phenomena make mercury too dangerous even at very low concentration. So we use gold nanoparticle electrode deposited on glassy carbon for analysis of mercury 2. Okay.
Okay tak tu?
For analytes that being analyzed, the electrochemical determination of mercury at trace level. Heavy metal ion constitute a major problem with respect to environment and healthiness, not only because they are widely distributed in natural system, but also due to the great hazard that they represent towards living organisms. Mercury appears to be one of the highest priority targets since its strong affinity for biological compounds emphasizes its toxicity. Mercury compound, and particularly mono and dimethyl mercury, accumulates in vital organs and tissues and are responsible for chronic disease and can also induce death. Mercury analysis, quantification, and speciation in the environment is one of the most challenging research fields for analytical chemists aiming at environmental survey.
So next is for the concentration of analyte use. So this mercury 2 plus is the analyte we use. So this journal, this work aim at the determining very low concentration. Dalam journal ni dia tak spesifik pun berapa concentration goal ni, tapi dia cakap dia memerlukan very low concentration, and for the limit of detection was estimate to 0.42 nanomolar, and the response of the gold nanoparticles glassy carbon electrodes was linear in the range of 0.64 until 4.00 nanomolar. Next.
Next, discussion about electrochemical response of mercury 2 and gold nanoparticles, glassy carbon electrode. As you can see here, the solid line actually a typical square wave analytic spin voltammetry signal recorded at gold nanoparticle glassy carbon electrode is equal to n equal to 4 in 0.01 molar HCl solution containing mercury 2 4 nanomolar using Pg equal to 300 seconds. So the dash line is a typical square wave analytic spin voltammetry signal recorded at gold nanoparticle glassy carbon electrode in a 0.0 mol HCl containing mercury 2 4 nanometer using Pg equal to 30 seconds, and a dotted line is a typical square wave analytic spin voltammetry signal recorded at a gold nanoparticle glassy carbon electrode and equal to 4 in 0.01 molar HCl solution. The extent of mercury 2 using Pg equal to 300 seconds. And insert this resulting signal after subtraction of dash line from solid line. Next.
Next, for the optimization of mercury surplus detection at 4 nanoparticle glassy carbon electrode. First, in order to optimize mercury filtrate determination on low nanoparticle glassy carbon electrode, the influence of varying the number of cyclic potential scan on the electrochemical response of a 4 nanomolar mercury plus solution was optimal. An maximum was observed between 283 equals to 157 microcoulomb for number of cyclic potential scan of 2, and between the RMG at 260 microcoulomb for the number of cyclic potential scan of 4. It is noticeable that the peak current is correlated to both 4 nanoparticles density and size rather than to the total amount of chemical deposited rate. The higher current being recorded for a high density of small nanoparticles. The result highlight the importance of a careful prioritization of 4 nanoparticle deposits, especially in the case where the modified electrolyte is devoted to an analytical aim. Next. For the analytical performance for mercury 2 plus detection, the 2 nanoparticle glassy carbon electrode exhibited a good linearity in the range of 0.64 to 4.00 nanomolar with a correlation coefficient of 0.914. Next, as the concentration of mercury 2 plus went higher, the slope of the graph decreased due to the separation of the surface of the nanoparticle. It will be decreased by decreasing the time of the pre-concentration. Next, the limit of detection of the electrode is 0.42 nanomolar, which is below the guideline value given by WHO, which is 5 nanomolar, but it is higher than the other reported system with the electrode. For the conclusion, is Cyclic voltammetry is proved to be an efficient mode for spherical light strip nanoparticle electrode deposition. Systematic characterization of the electrode using cyclic voltammetry and FPGA for different value of N allow the correlation between gold nanoparticle density, size, and performance of mercury plus detection. The best electrochemical response were obtained for high density of 73 plus minus 3 particle plus per micrometer and of small nanoparticle at 36 plus minus 30 nanometer. Both nanoparticles density and diameter appear to be key features with respect to analytical performance. Lastly, the choice of electrodeposition method is important as it can give rise to different levels of control for nanoparticle characteristics. That's all from us. Thank you.
Okay, thank you kepada grup nombor 4. So seterusnya kita teruskan dengan kumpulan 5 iaitu dengan tajuknya A Simple and Efficient Cyclic Square Wave Voltammetric Method for Simultaneous Determination Epinephrine using a activated pencil graph electrode. Dipersilakan kumpulan 5.
Hello, dengar tak suara?
Dengar.
Dengar. Okay, so Assalamualaikum and good afternoon to Dr. Faizwan and our friends. So we are from group 5. Next. Okay, the topic of our research journal is a simple and efficient cyclic square wave voltammetry method for simultaneous determination of epinephrine and norepinephrine using an activated pencil graphite electrode. Okay, so the voltammetric technique that we use in this research study is cyclic square wave voltammetry or CSWV. CSWV is the combination of pulse technique in terms of enhanced sensitivity and cyclic voltammetry in terms of electrode mechanism. Cyclic square wave voltammetry is considered as one of the advanced and versatile technique in pulse voltammetry. The step through the regions of the formal potential of the electroactive species was studied in two directions. So these are the suitable application for cyclic square wave voltammetry. The first one is for analytical application. The second one is for mechanistic study of electrode processes. The third one is for electrokinetic measurement, kinetic informations of very fast electrode process. Not only that, but CSWV also widely applied in simultaneous determination of compound with similar structures present in various pharmaceuticals and physiological samples. Correspond to this research paper also focused in simultaneous determinations of epinephrine and norepinephrine. Next is the advantage. Cyclic square wave voltammetry shows a broad range of advantage over other voltammetric technique. As you can see here, the quality of cyclic square wave voltammetry experiment in terms of voltammetric data is attributed from the transition and hold potential during a pulse. So this lead to the increase in sensitivity. Next, CSWV has greater sensitivity, short analysis time, and have ability for significant reduction of capacitance currents. And the last one is cyclic square wave voltammetry is good for analytical determination and can be made at nanomolar level. So, next.
Okay, next is the electrode. The three electrode system that being used is the pencil graphite and electrochemically pre-treated pencil graphite as the working electrode, the platinum wire as the counter or auxiliary electrode, and silver chloride as the reference electrode. Why we use PGE as the electrode? Because it has a lot of advantages such as low background current, ease of disposability, low cost and renewable, adjustable sensing area, and easy to handle. Next, the electrochemical activation of Pge. This is some sort of the electrode surface modification. We use modification because it can enhance the sensitivity and the selectivity. The Pge were prepared electrochemically pre-treated and fully characterized. The electrochemically pre-treated carbon presents more surface defect and increased surface area, which will facilitate the fast electron transfer at its surface compared with non-pre-treated carbon structures. The electrochemical characteristic of Pge, which depend on its surface properties, can be changed or improved either by pretreatment or by chemical modification of the electrode active surface. The effectiveness, the effective surface area of Pge that being pre-treated was higher than the normal Pge. Okay, next.
Okay, next on what samples are being analyzed. So for this study, human plasma samples were used to determine epinephrine and norepinephrine content level. So before I proceed, I would like to give a very brief explanation on what epinephrine and norepinephrine's are and why it is important to determine its level of content. So EP and NP are chemicals produced by nerve tissues and adrenal gland acting as a very similar neurotransmitters and hormones. EP and NP are involved in a wide spectrum of physiological functions and play essential roles in human body. So both EP and NP can affect heart rate, brain muscle activity, blood sugar levels, and blood levels. They also play an important role in our body's natural fight or flight response to stress. So these EP and NP have been investigated for over 3 decades because of their crucial role in neurotransmission. Changes in EP and NP concentrations can correlate with neurological and neuropsychiatric disorders. For instance, low level of EP have been found in patients with Parkinson's disease, while small concentrations of NP were found in a number of common neuropsychiatric disorders and neurodegenerative diseases. So EP and NP are widely used in the treatment of neuronal disorders and many other illnesses. Therefore, it is important to use selective and a very simple analytical methods for their simultaneous determination in clinical and pharmaceutical samples. Okay, for this study, the sample was prepared. Okay, the human plasma samples were obtained from a local hospital, and commercially available pharmaceutical injection solutions of EP and NP were used, where these solutions were diluted with phosphate buffer solutions with pH 7.4 to a final concentration of 2 to the power of -5 molar. So, like I said before, the fresh human plasma samples obtained from local hospitals were diluted 5 times with phosphate buffer solution of pH 7.4 in order to minimize the metric effect. And then appropriate amount of EP and NP was spiked to 10 ml of diluted plasma samples. For each pharmaceutical and human plasma sample, 3 additions of EP and NP standard solution were made, and CSW Voltammetric were recorded.
Okay, there are 2 analytes that have been studied in the experiment, which are epinephrine and norepinephrine. Okay, a few of the electrochemical methods that can detect these 2 analytes simultaneously. Okay, this because the structure of epinephrine and norepinephrine differ only by a methyl group on the amine side chain. Okay, these 2 analytes present very similar electro-oxidation potential, which makes quite difficult to distinguish when in a binary mixture. Okay, a binary mixture means the mixture of 2 types compounds. Next, okay, concentration of analytes. Okay, first, determination of supporting electrolytes, which is to find the best concentration and pH for supported electrolyte. Okay, 5 to the power of -5 molar of epinephrine and norepinephrine concentration were used to determine the efficiency of supporting electrolyte with different pH. As a result, 0.10 molar phosphate buffer solution of pH 7.40 was used as supporting electrolyte in the voltammetric determination. The second, voltammetric determination of epinephrine and norepinephrine. Okay, as we can see here, for the individual epinephrine and norepinephrine compound, the concentration range start from 2.5 to the power of -6 to 2.5 to the power of -4 molar. Okay, it same goes to the mixture of epinephrine and norepinephrine of compounds, which is the concentration range start from 2.5 to the power of -6 to 2.5 to the power of -4 molar. Next.
Okay, next, we are going to present about experimental result. The first topic is electrochemical behavior of epinephrine and norepinephrine at Pge. So EP exhibited two broad well-separated analytic peaks at around -0.25 volt and positive 0.08 volt, and only a single catalytic peak at approximately -0.25 volt appeared on the reverse scan at Pge, as you can see in figure 1 here. So for NP, two analytic peaks at about -0.21 volt and positive 0.15 volt, and two catalytic signals at approximately positive 0.15 volt and -0.23 volt were observed. So in equimolar mixture of EP and NP, 5 times 10 to the power of -5 molar each, during the analytic scan, two peaks appeared at the negative 0.25 volt and positive 0.15 volt, attributed to the oxidation of both compounds. So at the catalytic scan, the peaks that appeared at positive 0.15 volt and negative 0.25 volt may be attributed to the reduction of the EP and NP oxidation products. Thus, the oxidation process cannot be exploited for the simultaneous voltammetric quantification of EP and NP. Next. So the second part is voltammetric determination of EP and NP. So for EP determination, the peak current at -0.25 volt was directly proportional with the analyte concentration, as what Maisara mentioned before. So for NP quantification, a linear dependence between the peak current of reduction processes at positive 0.5 volt and negative 0.25 volt and its concentration was observed in figure B. And then although a better sensitivity was obtained for the peak situated at the negative potential, the signal at positive 0.15 volt was considered for the determination of NP. Because of this potential, there is no EP response. So the NP concentration was determined from the combined EP and NP signal at negative 0.25 volt by subtracting the NP contribution previously evaluated to the peak current recorded for a mixture of analytes. So the accuracy and the precision of the CSW voltammetric method for three concentration level of EP and NP separate determination are presented in table 2. Next. So based on the result of the percentage recovery and of relative standard deviation values, it can be concluded that PGE is useful and suitable for EP and NP analyzed in terms of accuracy and precision. So these are the figures A and B. So next. So these are the table 1 as what Maisara mentioned before, and this is the table 2 for the determination of EP and NE, the accuracy and the precision. Next.
For the conclusion of this journal, we can say that separation and simultaneous determination of epinephrine and norepinephrine in 0.10 molar phosphate buffer solution of pH 7.40 using an electrochemically activated pencil graphite electrode being presented using simple and low-cost voltammetric method. The simultaneous quantification of EP and NP in pharmaceutical and biological sample successfully applied by using the new CSWV method. And the advantages of this method is it is rapid and rapid, sensitive, the sensitive phase, it offers considerability promise for the sensor application. And the last one is it is not need using the chemical modifier for sample treatment and this possibility of the sensor. So this can avoid the falling from the repeated use. And that's all from
Okay, that's it from us. Thank you.
Terima kasih kepada kumpulan 6. Seterusnya dijemput terima kasih kepada kumpulan 5. Seterusnya dijemput kumpulan 6 untuk mempresent tentang bismuth nano powder electrode portraits analysis of heavy metals using anodic stripping voltammetry. Dipersilakan.
Okay. Can you guys hear me?
Yes.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon. Today we are going to present about the bismuth nanopowder electrode for trace analysis of heavy metals using anodic stripping voltammetry. So this is the outline of presentation for today, and I am going to explain about the technique of voltammetry. The technique of voltammetry that is being used is anodic stripping voltammetry. It is a voltammetric method for quantitative determination of specific ionic species. In this technique, the stripping step can be either linear, staircase, square wave, or pulse. As for this paper, the stripping step is square wave. Stripping analysis has been widely recognized as a powerful tool for trace metal analysis. Its remarkable sensitivity is attributable to the combination of an effective accumulation step and a pulse measurement which generates an extremely favorable signal-to-background ratio. Bismuth electrode is less susceptible to an oxygen interference, exhibiting a lower background current for square wave anodic stripping voltammograms, even in aerated solution. So the square wave anodic stripping voltammograms were experimentally measured for the Bi nanopowder electrodes as a function of the Pb and Cd concentration. And this technique is used to determine the ecotoxic metals using a bismuth film electrode. And this technique is able to detect multiple types of dissolved metal in one experiment. It is also fast and accurate, and it is easy to perform on site. So next is type of electrode. It will be presented by Azita.
So there are two types of electrode used to study: working electrode, contact electrode, and reference electrode, which were Bi nanopowder, titanium wire, and saturated polymer electrode SSCC respectively. So a counter electrode is used due to the excellent electrochemical inertness, super electrical conductivity, and good mechanical stability aqueous and non-aqueous solution. Saturated polymer electrode SSCC is for the reference electrode because the electrode is normally linked via a porous space to the solution in which the other electrode is immersed. This porous space is a fault bridge. So for the working electrode, we use bismuth nanopowder electrode. This nanopowder that has multiplicity by LDC was highly crystallized Bi with a high purity. They have some problem while using this electrode, which is comparably low detection limit and additional washing or polishing step of the carbon surface. To overcome the weakness, we have to develop a Bi nanopowder electrode with a large electrochemical active surface area. The sensitive response of the Bi nanopowder electrode is highly reproducible. So next, okay. The sample of analysis is the sample used for this in this article is heavy metal standard solution. So the standard solution used is MPP, cadmium and plumber. solution were purchased from Chemical Corporation, one of the chemical company based in Tokyo, Japan. And the density of the cadmium and Pg both is 1 gram per liter. And the solution is undergo accumulation step for 3 minutes at negative 1.2 volt under magnetic stirring. Next. Next.
Next is for the analyte to be analyzed. Basically, this paper focuses on the development of more sensitive and conveniently usable electrode sensor for a trace analysis of heavy metal by using bismuth nanopowder synthesized by LGC method. Bismuth electrode is used for a trace analysis of heavy metals. It is a new alternative to the common mercury electrode. Bismuth electrode is used due to its low toxicity and excellent resolution of neighboring peaks and insensitivity to the dissolved oxygen in a solution. So for the LGC method, LGC stands for gravitational gas condensation. It is one of the most promising methods for the synthesis of various metal or oxide nanopowders. It is also a simple one-step process to fabricate nanopowders with a more uniform particle size distribution. So basically, this paper used cadmium and plumbum as analyte to be analyzed. Next.
Okay, so actually the by nanopowder electrode is actually generating by LGC method using the micron powder feeding system. So in micron powder feeding system is actually uses micron powder and then added with a gas, and then it was shown that the bi nanopowder is in a spherical shape with size nearly to 50 nanometer. And then in LGC method, basically use repaste the conductive carbon ink into a flexible polyester film and then covered by an insulating layer. And then we disperse 0.0025 gram of bi-nano powders into 50 ml distilled water using an ultrasonic vibrator. And then we add 10% of naphthalene solution to actually for strong adhesion of bi-nano powders. And lastly, drop 10 microliter of the bi-containing suspension on the working area and dry in air at 298 Kelvin over 12 hours. So the supporting electrolyte that we use here is 0.1 molarity sodium carbonate and 0.025 molarity hydrochloride solution at a pH of 5. The standard solution we use here is cadmium with 1 gram per liter and then lead for 1 gram per liter. And then the accumulation steps is negative 1.2 volt for 3 minutes. And then we go on with the ASV step with negative 1.2 to negative 0.35 volt with a scan rate of 100 meter volt per second. And then we have a clean step with negative 0.35 volt for 30 seconds. Next.
Okay, now let's move to the result and discussion from this study. The first analysis is the XRD analysis, in which a crystalline phase of bismuth nanopowder was confirmed by an XRD investigation as shown in figure 3. In this, it is clearly seen that XRD pattern reveals intense peaks which can be indexed as rhombohedral structure of bismuth. No other diffraction peaks corresponding to an oxide or an impurity were observed from the XRD pattern. This indicates that the resulting nanopowder synthesized by the LGC method is highly crystallized with bismuth with a high purity. The size of the bismuth nanopowder was estimated to be 50 nanometer from the XRD pattern using Scherer definition. Next. Okay. For the square wave anodic voltammogram, figure 4 shows that SWASV experimentally measured for the bismuth nanopowder electrode in an unstirred solution with various concentration of cadmium and lead. From the investigation of the pH effect on the SWSV over pH range of 3.0 to 6.5, it was found that the voltammetric response increased slowly between 3.0 and 4.0, followed by a sharp rise between 4.0 and 5.0. A sharp decrease in the peak current was observed at pH higher than 5.0. On the other hand, the peak potential shifted shifted to a more negative value with an increasing pH. For a high sensitivity of the electrode, pH 5.0 was selected in the present work. A quite similar optimal pH of 4.5 to 5.0 was also reported in other studies. It was noted from figure 4 that the electrode exhibited a well-defined and reproducible response for a trace of cadmium and lead. The peaks which appear at negative 0.87 and negative 0.63 volt versus SCE, as shown in the smaller image, are closely related to the oxidation of cadmium and lead respectively. It was also noticeable that the peak intensity increased with increasing concentration of cadmium and lead. It has been well reported that absorption of surface reported that an absorption of surface active compounds and a complexation of metal ions result in a peak potential shift for stripping voltammograms. In particular, the Nafion coated electrode shifts the peak potential to a more negative value due to the cation exchange behavior of the Nafion coating, which favors an oxidized state of metal ions. From next. Okay. From the linearity between the metal concentration and the peak current, we can estimate the detection sensitivity of the bismuth nanopowder electrode. Figure 5A and B shows the peak current against cadmium and lead concentration respectively. The slopes of linearity were determined to be 9.01 plus minus 0.12 microampere liter per microgram centimeter square for cadmium with correlation coefficient of 0.997 and 7.15 plus minus 0.01 microampere liter per microgram centimeter square for lead with correlation coefficient of 0.998. This suggests that the sensitivity of bismuth nanopowder electrode is higher for cadmium than for lead. The metal concentration deposited on the bismuth nanopowder electrode increases with an increasing accumulation time. Therefore, as the accumulation time increases, the peak current is enhanced, which leads to an increase in the slope of the linear relationship between the peak current and the metal concentration. In addition, the peak current is significantly influenced by the SW parameters such as the SW pulse height, SW frequency, and SW step height. As the SW pulse height, frequency, step height increases,
The peak current increases in value, as shown in the okay, that's all.
So for the conclusion, bismuth nanopowder electrode has been proven to be highly sensitive and reliable for trace analysis of heavy metals in conjunction with an analytic stripping voltammetry. The high sensitivity and good reproducibility of the non-toxic bismuth nanopowder electrode makes it possible to apply the electrode to an automatic online system as well as a portable system for a trace metal analysis. The detection limits of 0.15 microgram per liter for cadmium and 0.07 microgram per liter for lumber were determined for a 1 microgram per liter solution under a 10 min accumulation, which are lower than the reported values for a bismuth film electrode. Next. Okay, thank you.
Terima kasih kepada grup 6. Doktor dah habis.
Okey, terima kasih semua grup. Dengar tak saya cakap?
Dengar.
Alright. Clear dah Okay. Clear?
Clear.
Saya cakap.
Clear.
Okay, nak tunjuk je baru beli mic baru ni.
Berapa doktor?
Adalah. Biasa je. Shopping. Sempena 12-12 kan. Okay. Semua grup dah present. Hari tu saya ada cakap kan yang presentation ni akan masuk final exam tu tak?
Betul.
Okay, saya nak ubah sikit lah. Okay. Final exam. Apa yang soalan yang akan masuk tu basically saya buat kantoi dah pula kan. Okay, biasanya soalan tu biasa-biasa je yang memang kita dah belajar. Kemudian nanti kita akan buat ulang kaji balik lah. Kemudian soalan-soalan daripada OGC pun akan masuk. Okay, maknanya OGC tu pun korang kena hadam juga nota-nota dia tu, tengok balik kan. Tapi dah banyak kali tengok katanya dah boleh cakap balik apa yang kita orang cakap masa OGC tu kan. Dah hafal lah. So, apa yang korang present hari ni, saya dah buat satu slot di e-learning untuk korang submit slide tu in term of dalam bentuk PowerPoint, in form of PowerPoint. Then saya akan compile dan bagi korang semua baliklah dalam bentuk PDF. Dan apa yang korang present hari ni, saya akan buat satu quiz untuk apa yang korang present hari ni. Simple je. Okay, based on what you all dah present. Alright. Soalan pun daripada slide-slide korang juga. On application of voltammetry. So basically kita dah cover semualah apa yang kita nak belajar pada SEM ni. Dan next hari Khamis ni ada satu lagi grup 3 akan present, betul tak? Ada kan? Ada member grup 3 kat sini, ada kan? Ke satu grup tak datang kelas hari ni? Ada kan?
Ada.
Alright. Ya ke? Cover ni Ada Ada betul. Okay, so hari Khamis nanti grup 3 akan present. Tapi grup 3 dah boleh hantar dah pun slide dia. Alright? Faham tak? Wakil grup je hantar slide tu dalam saya punya saya buat satu slot submission di e-learning tu. Wakil grup je lah yang hantar. So saya akan compile dan buat PDF bagi korang semua balik lah. Alright, so yang presentation hari ni pun saya record dan saya akan submit balik. Saya akan upload balik dalam e-learning. So hari Khamis nanti grup 3 akan present dan kemudian kita akan discuss test. Okay, kita akan discuss balik soalan-soalan yang keluar dalam test hari tu dengan jawapannya lah macam mana kan, dengan skema dia. Then kalau ada hari Khamis ni sejam je ada kan. So on the next class, kalau kita Khamis ni sempat, kita akan ulang kaji sikit lah, okay, untuk final. Tapi kalau tak sempat, the next class tu sampailah habis, kita akan ulang kaji je untuk final exam. Right? And penting final exam pun macam biasalah. Berapa markah final exam?
60%.
Berapa?
4.
Oh, sorry. 40.
Tak tahu 4 dia.
40%. Silap. Okay.
Alright. 40% di final exam. Dan don't worry lah, final exam apa yang kita belajar selama ni dekat OGC pun, dekat presentation pun, itulah yang keluar, right? Apa yang pengiraan yang kompleks semua tu yang saya tak ajar memang tak akan keluar lah. Tapi calculation still ada, tapi based on Voltammetric. Okay, apa kita ulang kaji nanti, kita tengok ni ulang mana, kita ulang kaji balik apa-apa yang silibus-silibus yang berkaitan, kita akan ulang kaji balik. Selain pada subjek ni, korang ambil subjek apa lagi? Tu ayam rumah siapa bunyi tu? Ayam rumah Nadia tadi kan bunyi, betul tak? Alright, so selain pada subjek ni, subjek apa korang ambil elektif ni?
Radiochemistry.
Chemical reaction process.
XBB, radiochemistry. Green, siapa ajar?
Green chemistry. Prof Hadinor.
Hadinor. Okay. Nanti Prof Hadinor Okay, Prof Hadinor pun insyaAllah soalan green chemistry pun macam saya tahu juga. Okay. Alright.
Doktor, apa soalannya?
Boleh tolong bocorkan lah.
Rajin-rajinlah datang kelas saya Okay. Alright. Basically sama je. Bila final exam ni, dia akan ada soalan-soalan yang betul application sikit lah. Kan? Sebenarnya soalan tu senang je. Bila kita pusing sikit buat application sikit konon-kononnya, korang jadi tak faham balik. Padahal benda biasa je. Sama macam belajar je. Tapi tak apa, kita akan buat latihan-latihan tu nanti. Alright, faham untuk kita ada next quiz, tapi based on application yang korang present tadi je. Okay, dan soalan pun true or false dan juga multiple choice je. Ke nak subjektif? Nak subjektif
Objektif.
Objektif siapa nak tu? Okay, kalau nak subjektif, saya buat subjektif lah.
Doktor, bila test, bila quiz?
Okay, quiz next week hari Khamis. Next Thursday kita akan buat revision untuk test, akan tengok balik test punya soalan dan juga group 3 present. Okay. Hari Isnin next week kita dah
Isnin ada kelas ke next week?
Ada, tak cuti kan?
Tak.
Okay. So, okay, memanglah kita punya syllabus dah habis tapi kita buat ulang kaji lah. Okay.
Okay.
So, Isnin kita buat revision sikit macam mana kan soalan-soalan. Dan hari Khamis tu kita buat test untuk based on today's punya presentation dengan group 3 nantilah. Tapi slide dah boleh hantar semualah. Okay. Ada apa-apa nak tanya saya?
Okay.
Clear?
Clear, doktor.
Okay. Ni hari ni Nida ada tak ni?
Ada doktor, tadi dia present.
Oh, ada kan? Okay.
Ada doktor, ada.
Ada
Tadi present.
Ada, okay. Ada Nida, okay. Tak, orang Batam kan, nak tanya juga khabar orang Batam. Alright, so tengok member kita yang Sabahan semua ada ke? Siapa
Ada, doktor.
Ada doktor.
Ada kan? Okay. Alright. So, okay, kalau tak ada soalan, kita boleh dah scan attendance semua?
Dah, doktor.
Alright. So, terima kasih Hecah jadi moderator hari ni. Dengan jayanya. Alright.
Doktor, markah lebih.
Nantilah akan dipertimbangkan. Sama ada markah lebih ataupun kita tolak markah pula.
Tolak.
Oh, ramai nak tolak Okay, alright. So, remember tarikh tu, next Thursday kita akan bincang test dan juga group 3 present. Next Monday, kita akan revision, ulang kaji. The next week, Thursday tu, kita akan buat quiz. Right? Okay, kata apa-apa, kita tangguh dulu. Kita jumpa nanti hari Khamis. Okay? Assalamualaikum dan bye-bye. Macam DJ pula saya cakap dengan mic baru ni. Macam DJ lah.
Yes, doktor.
Okay.
Thank you, doktor.
Alright, sama.
Thank you, Doctor.